Hi, welcome to this online demonstration on using Kafka APIs to build a real-time data integration pipeline in a microservice paradigm using the entire offerings from the Kafka API sets. This is actually a demonstration based on a Hackaday presentation with Desire.com. So Hackaday is a training course where we pick a subject and we try to treat it practically and try to bring it out. We try to treat that subject or that problem specification practically. For the most part, that is what a Hackaday session is. So in this session, we built a streaming ETL pipeline in Kafka, and we try to explore things like KSQL that comes with the Confluent Kafka offering. Also, our data set for this use case is the New York City Taxi and Limousine Commission dataset. Um, and you can get the dataset from this link. To find out more about the NYC Taxi and Limousine Commission, you go to this website. But we're more interested in the data. So to explain what we are trying to do, you come to the GitHub repository, you get all the materials as well as the source code for this course, for this Hackaday. And I am going to try and download this link. So the idea here is that, right, we have when you enter a taxi, you order for the ride. When you enter, the ride starts. At the end of the day, the ride ends, and that's the trip. Then you make a payment either by cash or credit card or some other form of prepaid accounts. So what we're simulating here is getting the trips data and getting the payment data, which we call fares, into to the server. And from there, we create a streaming architecture based on the Kafka infrastructure. And once you deliver that, that becomes your MVP, your minimum value product. Going further, you start building things in using the agile approach, use case based. And I said it's microservice because you're creating monolith application that will just perform one function. And that is what we're going to demonstrate in this section. So the idea is once the driver has completed the trip, has marked it as done, and the payment has been activated, all has arrived at the data center at the headquarters, we send this data into our Kafka infrastructure. Now, remember, Kafka is a durable messaging system that allows for real-time data or streaming architecture, or stream processing with microservice architecture. So we're going to be using the Kafka APIs, the producer, the consumer, the Kafka stream, and the Kafka Connect. And when I get to each part of it, I will explain what we're trying to achieve and what we're trying to bring out with that software. Yeah. So I have talked about the data set we're using, what we're trying to achieve. Now let's start the demonstration proper. So I have a VM, and in this VM, I have already started the um, Zookeeper service as well as the Kafka service. So what we're going to do now is look at the source code proper. I've told you where the source code is. I'm going to put the link in this video. However, you should also know that you can get it from, I'm going to put the link in the video so you can get the source code and everything we're talking about from this GitHub repository. Okay, so we're going to look at the code right now. And the source code, there are two parts of the source code, right? The first part is what we use to simulate the generation of data. So we're generating data by using this file reader Kafka producer to just read data from the downloaded data sets, and once or twice every second sends that data to Kafka, right? And that is all it does. So it reads it one line at a time, and it's a CSV. It reads it one line at a time and sends it to Kafka. The other application is the Kafka Streams application. It contains which we call taxi data service. and it contains everything we're going to talk about going forward. So let's describe it this way. Once the data has arrived in our Kafka streaming infrastructure, what do we want to do first? The first thing is to try to achieve data quality. So we have this class that we call the raw trip data processing service. And what it basically does is each event at a time, it tries to achieve data quality. And this is the place where you literally want to do things like denormalization, you want to enrich the data sets, you want to take care of bad data. For instance, if you go to the data set for this, you would see the definition of bad data. I mean, if you read it, they'll tell you what the definition of bad data. So you want to take action when you encounter the case of bad data, and this is where you take care of things like that. And once you have done all the processing, you will now send the data into another topic. In this case, we called it refined trip topic. So we read the data from a raw trip topic, we perform all we want to do, and we send it to a refined trip topic as JSON. Now, so from that single line of text, we're now creating a JSON object using the Jackson JSON libraries. So once that has been done, you also want to do the same for fares. So you do it for the payment and you do it for the trips. So in this case, there are two different payloads, which will probably come from different servers or different services in the industry. We're going to process them, and you know that Kafka is also a key value. Kafka data events in Kafka are in key value pairs, right? So we want to create keys and we want to create values. We also did an API for that. That we had an API that says the key, the primary key for every trip is the ID of the car, the ID of the driver, and the time, the pickup time. So that's the key. So we will use it to maintain. We'll use that in our entire evaluation to maintain primary key or the identifier. We'll maintain it as the identifier for that trip as well as the identifier for the payment. So once you have processed the fares or the payment data and you've processed the trip data, you will put them into their own refined topic. So, and this is what Kafka Stream does. So what is Kafka Stream? Kafka Stream is the API in Kafka that provides a very cool way to write mission critical real-time data processing and data integration applications in a microservice sense, right? And that is literally what we did here. So Kafka Stream in itself is like a consumer and a producer, and in between, it's a business logic, right? So, and that is what we did here. So we read the data raw, processed it, and we wrote it into a new topic. So if any application requires real-time data refined of this refined data, they would read it from the refined topic where we drop things in real time. So now that we have done that, we now have the data refined. However, we have not stored it. So based on our agenda, we were supposed to store this data in a HBase database. But we didn't do that in this particular hackaday. The reason being that when we ran a number of these use case, my VM began to freeze, so it became almost unusable. So for that reason, I chose to use an Elasticsearch database. So I put that Elasticsearch database in my host machine so that I can free my VM up for a little while. And we are going to be doing that in Elasticsearch. So I can try to hit the Elasticsearch server here by saying, using the IP address, sorry, that should be, the port number is 9200. Good. So we can connect to Elasticsearch. So once we stream the refined data, we will take this data and go store it in our Elasticsearch database. Cool. Now, this is the minimum value product. We are ready to go live with this, right? We can get data, we can clean it up, and can store it. If you need data at rest, you go to the database. If you need data in motion, you go to the topic. Now, in an agile approach, we're good to go. The next thing we're going to take on from here are now the use cases, and we're going to do about 4 use cases that I will talk through, and will also demonstrate. The first use case is we want to join the streams, and for this hacker day, each use case tries to bring out a feature in Kafka or in Kafka streams. The first use case is joining a stream. We want to join the two streams. Since we can agree that the key for the fares and the key for the trips will always be the same, how about we join them together so we have one full payload that describes the trip as well as the payment. So if you go to the class trip fare service or trip fare service using stream, so in this case I used a K table, and the other case I used a K stream and a K table. You can do any one. I just decided to do the same thing in two different ways. What we do first is we configure the properties file, just the same thing. We create a stream builder. Now we create a table from the refined topic, and we create another table from the refined trips topic, and another table from the refined fares topic. Then we join them. Now, because this is a K table, we expect to be able to join both streams together, given that our log retention will have both data based on their keys. That is one. And another way to think about it, if we use the stream, and the idea we wanted to bring up when we use joining of stream is the idea of the join windows. So there's this concept of windows in Kafka, and there are about I think 3 or 4 types of windows, and in all these use cases we brought out different kinds of what these windows are all about. However, in this join, you can see us using a join window. So we're saying this is a stream, and a stream is an unbounded set of events, but we're going to create a window in which we expect that the key, the payment, and the trip data will be available in that window. We will do a join. However, if it doesn't happen, then the join will be incomplete. So we kind of did a left join here. And you want to take care of the fact that one will be incomplete. So once we have done that join, remember, based on the key, we'll transform the data and have one full payload of JSON. So you'd expect that we'll write this to another topic we call merged trip and first topic. So the merged freeze and first topic will be a topic that now contains one payload for the trip and the payment. However, because I am using data that is it's old, and everything is not really happening in the natural time. This data is a data of 2013. If I try to create, yeah, and before I move into that, there's this concept also in Kafka of time. So there are 3 types of event time in Kafka, or time in Kafka. So there are 3 kinds of ways to talk about time in Kafka. First is event time, the other is processing time, and third is ingestion time. So in this project, I try to do event time, but then I am setting the data back to the time it generated, and that's like 2013. So the concept of time allows us to be able to get data in the order that they really happened, or in the order they arrived on the system, or in the order of processing. And that is what event time, processing time, and ingestion time is. The idea is Kafka is able to catch data and catch these events if they ever occur out of order. And you can determine how it treats them. But that is the idea we're trying to bring out here, especially in our join window. So we created a join window of 10 minutes. The idea is that in 10 minutes, if the trip and the first data are not with the same window, we're likely to get one of them as null, right? But this use case we're doing, what we're running right now, is not in the natural uh, uh, happening, so we can expect to get those kind of null values, right? So that is the use case. We join the two streams and we'll now put them in a new topic. So if there's an application within the industry or within the organization that wants the whole data at once, now they have it. That use case solved. We have another use case we call the popular grid service. Now, remember, we're using a data set from the New York City taxi and limousine commission. Now, what if at any time we want to know the hotspots in New York City in terms of pickup or in terms of drop off? So this is the World Cup season. You would agree that before a match in Russia, a stadium will be a popular drop-off location, and after the match, the stadium will also be a popular pickup location. So we want to always know at any point in time the trending areas in the city, and this is the use case that solves it. And you would see we read data from the refined trip topic, and we try to establish so we got a service that maps New York City into grid. So we're trying to know which grid in the city is a hotspot. And we get that value. And once we establish that it's in New York City, the grid ID becomes the new key for this use case. So it's no longer the driver ID, the time and drop off. No, it's now the grid ID becomes the new key. And we do a group by key on the streams with window. So the other thing we're trying to bring out here in Kafka is the idea of windows. I've talked about join window before. Now, in this case, we're talking about hopping window, or what I prefer to call sliding window. So we are creating a 5 minutes window that advances every 1 minute so that you can get to the minute the popular locations for pickup and the popular locations for drop off. So at the end, we do a reduce. So we map and we reduce and we get this new stream. And you can see we're even printing out the key of the window. So we get the window and we write it into the trending pickup grid topic. So you can have a web application that subscribes to Kafka, reads from the topic, and creates the top 10 or top N trending pickup and drop off location. That's a cool information. So this solves this use case. The next use case is an accounting use case. So you can imagine every time what we want to do in this use case is that we want the drivers to get their monies as quick as possible. So we determine that every 3 hours we will pay the drivers for what they've done for that window, 3 hours window. So between 12 to 3, they get a payment by 3, they get a payment by 6, they get a payment by 9, they get a payment by 3. This is going to encourage drivers to keep working because they work in 3 hours, they see what they're working for, and it makes life very rewarding for them. So we used another kind of window here, and that window is called is it tumbling window, or I like to call this fixed size window. So it doesn't matter the name. You can go to the Kafka. You can go to the Kafka. Um, you can go to the Kafka documentation and get the name. One is tumbling, which is the fixed size. Hopping is this one I call sliding window. And this now they call it sliding time window, which shows works on the difference between the recorded timestamp and this is session window. These are different types of windows. But what we're using now is the fixed size non-overlapping window. So we're only going to pay you for what worked between 12 and 3, right? But the difference between this kind of window and the window we used for the sliding window is there's a window between 12 and 3. There'll be another window between 12:01 and 3:01. And you just keep going like that. But because this is money, we don't want to play, right? We want to pay you once and exactly once. Another concept we also try to do here is the exactly once semantics that comes with Kafka. That means the delivery guarantee that Kafka is going to deliver this event only once. Now, before Kafka 0.11, the only delivery guarantee with Kafka was at least once. So it will always deliver it, but it might duplicate some events. But now we don't want to duplicate payments. we don't want to play. This is money, right? So we want the data exactly once. So we have this exactly once semantics and also the concept of um, fixed size tumbling window. So we also did something here. Now, when you do payments, I'm going to pay you $20, but paying you $20, I also want to say that $20 comprises 3 trips. So you ran 3 trips in the past 3 hours. So I'm going to just create a summary payment and also a detailed payment. So that when we send him the message, he sees the full money and everything in between. So we sent the data to 2 topics. One is the driver payment statement topic, and the other is the driver payment summary topic. And we used materialized string here because we used the through and not. So think those in a nutshell. So this is where we used a tumbling window as well, timed windowed case stream, and we did aggregation. Also, we also applied the business logic of sharing the money. So let's say the trip is $5. A portion of it is tax, a portion of it is commission, a portion of it is due to the driver, a portion of it is due to the transport company, and there could be a lot of business logic around sharing that money. You want to do all that in there and send the money to the driver. So that is what we try to portray in this use case. Last but not the least is the income statement service. So the income statement service also uses exactly one semantics, but the idea is once the trip is done, we want to do real-time accounting, right? So we want to do real-time accounting. Once that trip is come, we'll want to credit the ledgers that we should credit, debit every ledger we should debit, and make sure we're done with accounting for that single trip. So that is the idea. So once again, we need exactly one semantics. Now, also, we have not finished writing this code, but the idea here is that it's going to be exactly once. The accounting things will be defined. So I'm not so good into account. I'm not an accountant. But the idea is once we get the first payment, we should balance every book possible. We are not doing the accounting. What we're doing is getting the data and writing it in an accounting way such that the accounting applications can subscribe to that topic, pick it, and do the real accounting operation. So we're not doing the accounting itself. We're just taking the data, doing whatever we should do, and just sending it. Once again, in this case, we really don't need a window, right? Because we're processing every event as they come, right? So now that we have listed some of all this, let's go into the implementation proper. Cool. So the first part of this implementation will be that we need to create all the topics that we require. So there is this Kafka topic file. It contains a list of all the topics. And you can see we create the topic replication factor one, partition one, right? You can scale this application horizontally. And normally you want to do partition more than 1, 3 so that you have at least 3-degree parallelization. You can scale it as the events begin to occur, as you begin to grow. You can now scale. You can now run 3 instances, and that's the beauty of Kafka Stream. It's just plain Java application, and all you need to scale it is just run another instance of the same application, and it's going to do the load balancing itself, right? And in this hackaday, we actually demonstrated all this stuff. So we are just going to create it, and what I'm going to do is just run through all this and create it. Before we do that, let's see if we have any topics. Let's see how many topics we have. Zookeeper. This is going to be data dev, and as the host machine, 2181. Oh, sorry, 2181. Cool. So we don't have any topics created yet. So we will just copy everything here and we hope we don't get errors. So it's just going to create all the topic I need. And this is the merge topic. Every topic we have just all the topic that we need to describe everything we've talked about here. So having done that, before we proceed any further, we will have to build our application. Now, to build this application, We'll go into the application. We'll build the two applications. The first will be the file reader, the one that should read the file and send it to the one that should read the file and send it to Kafka. And this is a Maven project, so just say Maven package. It's gonna build the Maven project. While that is happening, I think we should also build our Kafka streaming application as well. So Maven package as well. Okay, so why files are being downloaded? Let's take this time to set up our Elasticsearch database and create mappings, right? So that when I come to the topic of Kafka Connect, you can see how we get data from the topic in real time and store it to the database. And the mapping, the file for the mapping is in this file called Elasticsearch index mapping. So if you look at it here, you would see the mapping for a trip and the mapping for fares. Now, because I don't have a lot of computing resource, I'm going to only do one mapping, and I will urge you to do the others, right? If you can do two, you can do. If you can do all, that'll be fine. So I'll copy this. This is the mapping, and it's called. So I'm going to copy it like this. So I'm using Postman now because I'm not such a command line person for JSON. So I use Postman as my REST client to Elasticsearch. Remember, Elasticsearch is localhost here 9200, and then I am trying to put a mapping. This should be binary and it is JSON. So I paste it right here, and the name of the mapping is, or the name of the index is NYLC TLC trips. So the other one is for fares, but I'm just going to focus on trips. So I'll execute. It says this resource already exists. Okay, cool. If already exists, let's just check at this. Sorry. Good, it already exists. Let me delete this first. Need to be sure doing the right thing. So I'll delete this. Right, then now I want to do a new one. Good, execute. Good, so I'm creating the trips data. Now once created, we're good. We can count how many records we have in there. Let's use a post here. How many records do we have? We have 0. We have the default 5 shards and I think 1 replica. Good. And also, there's something because most of these things are back end, you cannot really see this operation. What I did was I installed Kibana, which is a visualization tool coming with the Elastic suite. And I want to use Kibana to kind of make, let me copy this, to just create a little visualization so that we are able to see what we're working with, right? Okay, so I'm going to refresh this. I don't know why I cannot see my indexes. Go to management, index patterns. Gonna paste index pattern here, NYSC, NYC. So it cannot see it yet. Okay, so when we put data, we will come and check for our index. For now, we can't find it. So now it's time for us to run our application. We have created all the topics and we have built the job. So the command to run all the applications, you'll find them under this note, command.txt. So if all is built, I will close this page. This I will close the IDE, and we see that they're all built. This will be file reader. This will be file reader as well. So this is where I will stream the trips. This is where I will simulate. I'm not streaming it. I'm simulating the fares. Then this will be for the raw. This is where we'll run the raw trees processing. We'll create another terminal for the first processing. We will do the join here. We will do the popular grid here. We'll do the periodic payment here. We'll do the income here. We'll do Elasticsearch here. And finally, we'll do Kafka Connect. So you see, there are a lot of applications that's going to run. So the command to run the fares data will be this, right? This is fares. And by the way, the dataset we used, I downloaded it. You come right to the dataset folder in the material. You see the link to download it. And these are the ones we downloaded, right? 11, 11, 12. But we're just going to use one, right? And I've told you about the documentation before. So I've already downloaded them in my downloads folder. I have datasets, I have the trip, and I have the fares. Good. So having said that, let's just go execute the command. This is, we'll run the trip data, right? CD on space, we'll run the trips data. So we run file reader. Oh, sorry, I should have, that's wrong. CD file reader. So I'll paste it here. We are looking into the target directory. Target directory, right? And this is for trip, right? We'll go to the next. Right here, we'll do the same for fares, right? So this is the command for fares. I'll paste it here. And once again, we're doing it for target directory. Should be target. Good. So we'll run that, but we're not going to start that yet. Instead, what we want to do is we want to start up all our streaming applications. And the command to do that, once again, you find them here. You will run the trip processing application here, execute it. Good, it's good to go. We'll do the fares as well right here. So streaming applications are long running applications. They just run. Then we'll do the trip fares. This is the guide that will merge the two streams together. We'll go here. I prefer to use the other one I call using streams. Let's see. This one uses ktables and the other use windows. It will do the same thing. So I would run this right here. Good. Then this is for popular grid service. This is the one that's supposed to tell me which area of the town is the hotspot for pickup and for drop off. I'm going to paste it right here. Good. Application is good running. This is for payment of the driver, periodic payments, right? That uses exactly one semantics. Drop it right here. So you see, everything now is running, and they're waiting for us to execute this. So finally, see, because this is run behind and you won't see any printout, so you won't. So if I tell you it's working, you wouldn't know. What I want to do is I want to create a console consumer, right? So that we can see the streaming live. And one will stream from the raw, and the other one will stream from the refined. So this is trip raw. This one will take data from the raw trips, and we will do another one that will take from the refined. So at least if it's working, you would see it. If not, just looking at these applications, you won't see anything. The other way we would know something is really happening is using Kafka Connect. So what is Kafka Connect? Kafka Connect is a tool, also an API, that scalably helps us to scalably and reliably stream data between Kafka and other systems, all the outside world. So you want to get Kafka, you want to get data into Kafka from the outside world. You can use producer APIs. You can also use Kafka. So you can also use Kafka Connect to get data from Kafka to the outside world. In this case, our outside world is Elasticsearch. So Kafka Connect has, especially the Confluent offering, has tons of connectors. And you see with this list of connectors, you can, I mean, there are rarely any systems in this planet that you want to connect with Kafka that you cannot use. For example, you can use it to get trading signals from Bloomberg. You can get news feed, trading feed, Yahoo Finance. You can use Kafka connectors to connect all these kind of systems. Elasticsearch, HBase. I'm just trying to get you the list. Just excuse me for a second. Now, this website changes very frequently. Let's go look at it. So also in this Hacker Day, we also discussed the difference between Apache Kafka and Confluent Kafka, right? So you see in this case, I'm going to Kafka. I'm looking at the Kafka doc, and in this other case, I'm looking at Kafka Connect. So you can see list of connectors. With messaging servers, you can see we can talk with messaging servers. We can talk with NoSQL databases, MongoDB, Cassandra, Amazon S3, HDFS, Kinesis. You can talk with Bloomberg, you can talk with Vertical, and the list goes on. Even blockchain. I think there's a blockchain connector as well. Let's see if it's here. It's not here. Okay, but I have seen a blockchain connector as well. So the list is the list just goes on and on. Give me a second. Kafka blockchain connector. Yep. Cool. There is a connector. That's it. That's the project. There's a connector with blockchain. So whatever systems, Yahoo Finance, Bloomberg, and the list goes on. So you can get news at real time. You can get trading signals at real time, and the list just goes on. In this case, we are using, even though I said we're going to use HBase, but like I said, VM is already heavily used. That is why I chose to go out of the machine and use Elasticsearch. But the process is the same. So you can run Kafka Connect in two modes, distributed mode and standalone mode. I am using the standalone mode. And to do that, you just say connect standalone. Then you specify two properties file. The first file is for the connector APIs itself, right? That's where you set up um, the Kafka broker, you set up the key converters, you set up yeah. So if you're going to probably use Avro as conversion schemas and everything, the properties, that's where you set them up. So if you come to the project, go to connect, go to sync, Elasticsearch, we have the two properties file here. So this connect standalone property is the one for the connector. So that's where we'll specify the broker, the converters, and all the properties it requires, as well as the class path. So we're trying to extend the API. And if you notice, I am using Apache Kafka, but I extended it to use the Confluent APIs. So that's how I was able to use the Elasticsearch APIs. Cool. So yeah, pretty cool. I'm using a Confluent, even though I am using Kafka. So you can see how pretty that could be. So the other properties file is actually the connector itself. This is the guy. The name of the connector is strip sync because we are trying to store the refined trip data from the Kafka topic into Elasticsearch. And this is the connector class. Remember, you can create custom class if what you want to do doesn't exist. We're picking data from this topic and we're writing it to this index using this index mapping. The name of the type name is trip and the index name obviously is this. So let's execute it. We will execute it by specifying, this is wrong. I'm going to connect. So I'll say connect standalone. I'm doing sync, Elasticsearch, and connect standalone. Then I also, the properties file for what I need is Elasticsearch and this will be sync. So this is for the connector and this is for, okay, this is for the connector API and this is for my connector. That's the way I say it. Execute, and you wait a moment. It's gonna try to search the entire tree of the class for the plugin. You see, it's picking up my Confluent APIs, right? Picking up all my Confluent APIs. It has identified HDFS connector, schema source connector, Avro converters. It's just looking up everything. You can see S3 connectors, all the connectors it can find. You can see them all right here. Cool. So in Hackaday, it's normally boring. I would tell you it's boring and educative. Boring because when we do this, we meet a lot of errors and we debug. It's full of debugging sessions as well because it's live coding, and yeah, we would have encountered things by now. So you see, we can now connect here. So given that my connectors is ready, my console consumers, they're already waiting for data to process. There's only one more thing I need to do, and that is just execute this code to start picking up data. So it says first does not exist. So what I'll do is this is dataset. Um, this is trip phase 12 CSV. Am I correct? CSV. Okay, let me check this other guy. Actually, yeah, I got the same problem. So, so this is trip. What's the one I'm looking for? This is trip data, right? Trip data 12.csv. Cool. So this gives me trip data. I already got errors. I don't know how it's going to affect me. Then I also run the one for fares. Okay, how do I know it's complete? This is just the simulation of data being generated. I'm going to go to my console consumers. I'm already having errors somewhere. Okay, so my console consumer is working. So I'm streaming data in, and this is for trips. This is for the refined. So you see, so this is how the data comes in line by line into my Kafka. Then when I finish processing it, this is what I get as the payloads, JSON. And this is the key which composes the driver ID, the car ID, and the time. So you can see the streaming is taking place. Now let's see the other services we're running. So you can see nothing is happening here, which just tells you that our raw processing is working. The raw processing is working. There is a problem with joins in our joining. So something happened and it's a null pointer and this part of the code. I don't want to open the IDE because just my machine is gonna hang, but it's easy to fix this. It's a null pointer, and this is because it's kind of does is the left join. So there's something that one of when you do left join, you get the value in the left, and the other can be null. So that is what I expect. It's why this is null. Okay, this is the periodic payment. So you can see we're printing out the window we're in. So you can see window changes every time. Cool. And this is, I can tell which one this is. Let's do. Okay, so this is another error. Okay, but we're just gonna stay. I need to figure out which one is this. Oh, this is the periodic payment service, and there is a class cast exception happening inside the internals. Okay, I can almost tell what this is. So if we just leave this code to run, you can see that our streaming is happening. And does everything stop? No, right? And this is why it's very agile. The fact that this guy failed does not mean the other guys failed. I can now fix them. If I can fix them outside this place and deploy this and execute this again, it continues from where it stops, right? So you really want to have notification to know that this streaming application has encountered errors, and I need to go fix it. So it's shut down. So we have two of our streaming applications that are buggy, but our Kafka Connect is working. So what we want to do is go to Elasticsearch and see what We had 0 before. If we'll execute, now we have 333. Execute again, we have, see, data keeps coming in. You want to see the format of the data, it's a search, and that's it. We have 354, and this is our data. Cool. So this is an end-to-end. This is how it works. And what about KSQL? So Kafka SQL provides a whole new opportunity, a whole new paradigm that allows us to do this kind of data processing, ETL processing, data inspection. I mean, the possibilities are many, but using a language we're familiar with, SQL. So we call it KSQL, but it is very close to SQL. And instead of you to write code, because you can go and see that when I open the code almost they always do, they all have the same way of behaving, right? You create properties file, you create your stream builder, you create your KStream or K-table from your stream, and the same thing. But what if you could just do everything that we just did with a command line? I mean, with a SQL-like statement. That's the opportunity KSQL offers us. But you see, we don't have KSQL with in Apache Kafka. We have KSQL with Confluence Kafka, right? And we're not going to do that in this video. So last but not the least is I will go to Kibana and try to find my service now. NYC, let's see, now I get it. Cool. I didn't see it before. Now the time filter field, I want to use drop off, right? And I'm going to create this index pattern. So if I go to discover to look at what I have so far, I will say find, we get nothing. So we can get a list of all the fields here. But what I'm going to do is I want to move this to absolute time and I move this to 2000. So that's 2010. Let's see. Good. So we get data like from like 2014, right? So just go back and say 2013. Good. So we get, you can see data and data for 1 day because we just started streaming. So you can see data is coming in, and let's just do something to make it like pretty cool, right? Let's create a visualization and check out a map. And in this map, we want to see the hotspots that we talked about. Yeah, since our stuff failed, let's see if we can get some hotspot to find the hotspots for drop off. Let's execute this, and you see it's in New York, right? So how do we drill down in here? Is there a way? Cool. I'm just going to click this, execute. Just keep going in. So you see we're in New York. I'm trying to see how far we can go till we get into New York City. Execute, execute. Good. We're there. We're almost there. Almost there. Okay, this is the last we can do. But you can see the locations in the city, right? You can see the real hotspots, and as data keeps coming, you keep refreshing, you see data, right? This is 276, refresh, look at it now, it's 280, and you can see these parts. Let's see if we can use shaded markers, execute, that's it. So this is really city center. I've never been to New York before, but if you can zoom into the map, you know why. Probably here is really red because a lot of things are happening right there. Right. So that is an end-to-end. You can see you can do accounting, right, with the transaction features. You can there are a lot of also other functionalities that I didn't talk about, things like state store and diving more into time and time event time, diving more into Windows. But I hope we have more Hacker Day session with Desire.com. And when I have the opportunity, I could share the same thing the on YouTube, or I can share things in video like this. So we can go and see that our streaming is still taking place. We're now very sure, so we can kill our console consumer. Yeah, can kill this. We are also setting that it works. Let's see. But anyway, if it hangs, we'll just kill the video. But we have exceptions and want to see how we can really fix exceptions like this. So So the first is trip fair service. We line 75. We have problems with trip fair service. We'll click here and 75. Yes. So it turns out that fair node is null. Okay. But fair node was not null. Okay. It turns out that it's the amount figure that is null. So this looks like bad data because these fairs we should have amount. Right? And what I'll probably do with this kind of thing is when you have this kind of case where how can we have a fair payload without amount? I will want to take this, I will throw an exception right here. Then when I come to the code, where is the code? Right, in this place, when I come to the code, I will want to route this kind of data to another topic or throw an alert, right? That's another thing, using error specialized error notification software to say we have problem with this kind of data, right? Because it's going to be a data problem for you to have no fair amount and you're dealing with data. So that's a problem. Let's see the other issue. The other issue is going to be with, I think the problem is with periodic driver service. And it says that cannot be cast to string. So an object node cannot be cast to string. That would probably have happened inside our window store. So let's look at what we did with K window stream. Okay, so if you look right here, where would that be taking place? We have a timed K window stream right here, and we tried writing. Let's see. So we wrote here, and we are writing a stream. So we said produce with a, so we're saying the key is a stream. Let's see how we did it here. We mapped the window, right? We mapped the window and we got a key. Let's see. Yep. So it considers this value. It says this is not a string, that this is an object node, right? So we probably want to walk through to confirm that this is object node. Another way you want to be sure about that is just to put a print line like I did right here. Put a print line, then you print the key, you would know if it's an object node or not. Okay, so that's just you put the print line, object node. When you see it's not an object node, when you see the real time, then you can call that accordingly. Okay, so that is it. But you see the debugging part of it and the working part of it, we can go back to our visualization and we'll confirm that things have really increased. Good. So hope to see you next time. I hope this has been helpful. Cheers.